You assign a complex, open-ended project to an artificial intelligence. You hit enter, wait 3 seconds, and receive a massive wall of text that sounds vaguely professional but is entirely unusable. The specific intent of your project loses all shape in the machine's response. The modern reflex to solve this problem is to purchase a prompt pack or scour the internet for a template to copy and paste. We look for a shortcut to bypass the friction. But lifting someone else's prompt strips away the exact details that make your project distinct. You feed the model a generic template, and it predictably returns perfectly formatted, perfectly hollow garbage. We fail at these tasks because we expect a pre-packaged string of text to substitute for actual cognitive work. This frustration stems from treating AI like traditional software. We are used to deterministic computing, systems operating like calculators, where identical inputs will always yield identical, predictable outputs. 2 plus 2 is always 4. But look at this diagram comparing a standard calculator model to a large language model. An LLM is a probabilistic engine. Instead of retrieving a static answer, it calculates the statistical likelihood of one word following another, generating a new path every single time. Using a prompt library to navigate a probabilistic system is like tailgating a stranger on the highway. You are certainly creating forward momentum, but you have zero control over your actual destination. To get exactly where you need to go, you have to get out of the passenger seat and learn how to drive the machine yourself. The moment you submit a vague, unconstrained request, the model enters a massive mathematical space to construct a reply. The engine instantly maps out billions of linguistic probabilities, evaluating countless directions for your prompt. Without specific boundaries, the math defaults to the safest, most statistically average path. It converges on the mean of human knowledge, bland, predictable, and uninspired. The mechanism you use to disrupt that mathematical default is input design. The constraints and rules you feed the model actively alter its trajectory. You cannot change the raw computational horsepower of the engine, but deliberate input design gives you the steering wheel required to control its exact direction. The moment you inject your unique human context, your specific audience, your specific stylistic quirks, your exact goals, the system reacts mathematically. Providing active human context instantly severs massive sections of the probability tree. Irrelevant outputs are actively dissolved. As you stack more variables, the tree narrows further, forcing the model down a singular, highly specific outcome it never would have discovered on its own. You aren't typing the final words yourself, but your continuous, active steering is what pulls the machine away from its generic baseline. Producing a highly specific, expert-level result relies entirely on an operator who knows how aggressively to prune that probability tree. Knowledge work now requires input design as a foundational skill. It is the method used to bridge the gap between human intent and machine execution. A powerful language model is exactly like a powerful motor. It generates incredible force, but sitting alone on the floor, completely disconnected from a chassis and steering column, it is useless. No one mistakes an engine for a finished autonomous car. In tightly defined, repetitive software tasks, developers can build the guardrails directly into the system. But in complex, open-ended work, where judgment, nuance, and context dictate success, there are no pre-built tracks. Without a human operator actively overseeing the variables and making judgment calls, the system will inevitably fail, regardless of how much processing power sits under the hood. The modern workforce is splitting into 2 distinct categories: passive passengers who copy and paste templates, and active drivers. The passengers are locking themselves into a stagnant fate. They will consistently produce average, easily replicable work. Those who master the controls and learn how to steer probabilistic outcomes gain precise control over the machine. They produce work that remains out of reach for anyone relying on a template. The ultimate limiting factor of artificial intelligence is not the horsepower of the engine, it is the skill of the driver.